Hello and welcome to the 2026 Design Expo. My name is Nolan Besaw and I'm going to tell you a little bit about the enterprise and go over projects we've been working on and share our plans moving forward. Who are we? The Aerospace Enterprise is a group of undergraduate students collaboratively exploring the space industry through various hands-on projects. The program brings together students from disciplines across campus to design, build, and test multiple small satellite platforms. The enterprise has two primary objectives. The first is to educate the future leaders of the aerospace industry by providing undergraduate students with hands-on space systems engineering. The second is to advance the U.S. space technology by solving real-world problems. These missions are directly relevant to current U.S. military and NASA needs. Program statistics. The program was founded by our academic advisor, Dr. Brad King, in 2001. Since then, it has helped over 700 students obtain their undergraduate degrees from Michigan Tech. We currently have 100 active members from 13 different disciplines across the university, and that number continues to grow each semester. We operate out of two on-campus facilities, the Aero Lab located in the basement of the beam and the clean room located on the first floor. We are actively funded by two well-known organizations, the Air Force Research Laboratory and NASA. Speaking of those upcoming satellites, the Enterprise now has two active orbital missions, the Auris mission and the Stratus mission. One of the most pressing problems in modern space industry is orbital congestion. With the commercialization of space, the space environment grows busier every single year as more companies send up satellites to conduct scientific and commercial missions. Over the past few decades, space technology has advanced to the point where satellites can now be smaller than a loaf of bread. This reduction in mass and volume makes launches extremely cheap, meaning the space environment is now more accessible than ever. That increased accessibility has led to thousands of new active spacecraft in orbit, creating significantly more traffic in space. Just as cars on a road increase the risk of accidents, the more satellites in orbit increases the risk of collisions. Auris is our response to this challenge. Auris is a pathfinder mission whose goal is to demonstrate a low-cost platform capable of exploring the interference potential of geostationary satellites. The mission features a small satellite, roughly the size of a shoebox, that will measure the antenna beams of communication satellites to better characterize the activity in space. Modern communication satellites can create both electrical interference and physical interference through risk of collision with other spacecrafts. The Auris mission addresses both types of interference in an effort to advance space domain awareness. So how do we plan on accomplishing this? The answer is beam mapping. As the Auris spacecraft flies through the RF antenna beams of geostationary satellites, it records the timestamp, GPS position, and signal power of the collection point. This data is processed through our custom onboard payload system to help map where the signal is the strongest, where it's the weakest, and the overall footprint it produces over the continental US. Now let's shift to our Stratus mission. The Stratus mission aims to demonstrate an inexpensive, scalable architecture capable of imaging clouds and generating data that can be used to validate and improve existing climate and weather models. As Stratus flies overhead, it'll capture images of clouds across the Keweenaw Peninsula to help us understand average cloud coverage and improve our climatology models. Images will be processed to distinguish clouds from ground pixels, and over time, this data will be compiled into models that help us better understand if solar panels are a viable solution. In addition to our orbital missions, we also have two in-atmosphere projects. The first is the Descensus mission, a CubeSat mission, meaning the satellite is roughly the size of a soda can. Funded by NASA, it conducts a small-scale in-atmosphere research to advance U.S. technology. This year, the Descensus team has been tasked with designing and develop a paraglider delivery system capable of transporting a sensitive instrument, in this case, an egg. The mission follows a multi-stage flight profile. Ascent, where the CubeSat is carried to altitude via rocket. Shell separation. At apogee, a pyrotechnic charge separates the outer shell. Parachute descent. During the first 20% of the descent from apogee, the payload descends with the shell under a parachute. At 80% of the peak altitude, the paraglider deploys and separates, and then payload release. At 2 meters above the target zone, the egg compartment is released for final descent onto the drop zone. The core engineering challenges here involve autonomous navigation, precision deployment timing, and ensuring the structural integrity of the payload through each stage of the transition. All with very, very tight size and mass constraints of the CubeSat form factor. Our second in-atmosphere project is the Connexus mission. The Connexus mission is an internal server and database platform we are building to help manage the enterprise as a whole. Connexus will serve as a centralized system for tracking personnel, inventory, and finances across all enterprise teams, improving accountability and organization program-wide. Some of the key subsystems we're implementing include simulation tools, inventory management, personnel tracking, and finance tracking. The goal is for Connexus to handle it all in one unified platform. For the timeline, we are targeting a minimal viable product by the start of fall 2026 semester. Beyond that, the Connexus mission is intended to be a continuously evolving project, one that grows alongside the enterprise indefinitely. Recent progress. Before jumping into recent progress, let's walk quickly through how a satellite actually gets built. The process follows the path of space systems engineering. You begin with a mission concept defining the bare bones goal of exactly what the satellite would do. From there, you move into the requirement definition, deciding exactly how the satellite will accomplish each mission objective. Those requirements then guide the system design where everything is integrated together. This is the roadmap the aerospace enterprise follows for every single project. Auris is currently in the testing and integration phase, focused on what the team calls the Big 5 tests. 5 tests designed to simulate the exact conditions and tasks the Auris mission will face in orbit. The first ensures the spacecraft can configure itself into the correct pointing position to maximize solar panel coverage and maintain a downward-facing orientation for ground communication. The remaining tests verify that all other critical systems, such as the attitude determination and control, the power system, RF communication, all perform exactly how they are required to before we transition to the flight model. Following the completion of this campaign, Auris is expected to be handed off to our sponsor in spring 2027. Thanks to the generosity of Michigan Tech community and its alumni network, the aerospace enterprise was able to revitalize the Stratus mission a few years ago, bring it back from the brink to a fully active mission once again. The full satellite bus is now in-house. Mission software is being written and loaded onto the OBC. FCC licensing is nearly complete, and the battery test is going to be completed by the end of the semester. We are on track also to launch in summer 2027 with operations following shortly after. Conclusion. The aerospace enterprise would not be where it is today without the generous support of the Michigan Tech community, our ever-growing alumni network, and our dedicated student body. Thank you for your continued support. If you'd like to stay up to date with the aerospace enterprise, you can find us on Instagram and LinkedIn, or visit our website by searching Michigan Tech Aerospace Enterprise. We should be one of the first results. Thank you for your time, and we appreciate everything Michigan Tech has done for us. Thank you.